Okay, so really quickly, somebody asked about quartiles. If you go to Wikipedia, oh, you can't see. If you go to Wikipedia, they have method 1, 2, and 3. If you go look under quartile. If you want to figure out how Excel does it, read that. It's awful. I don't think you want to use that method, but that's method 3. That's the method that Excel does. So if you want to know how Excel does it, I think that's much harder than the method I was showing you. The method I was showing you was basically methods 1 and 2. One of them includes, one of them excludes. So you can review that, and that's it. So Wikipedia, there's your friend. All right, let's move on to 4.2, which is Ordinary Least Squares Regression. Okay, often abbreviated as OLS. Okay, now here is the idea with OLS regression is it minimizes the vertical distance between the scatter plot dots and the regression line. Okay, so here's what I mean by that. If you take a scatter plot, so I've got a bunch of dots here. Okay, I'm going to draw a line that fits that the best. Okay, with ordinary least squares regression, okay, I'm going to minimize the vertical, emphasize vertical distance. So this distance here is always the vertical distance. Now, just for comparison's sake, I could minimize the horizontal distance, this distance here, or I could minimize the orthogonal distance, right angle distance, just like this, okay? So there's lots of different methods I could do, or I could do some other method, okay? So what I'm telling you is ordinary least squares is, oh, and I found out that if I turn out this light, it focuses better on the camera. Ordinary least squares regression is the best line you can make. Okay, now, hopefully I have enough time at the end of class. I ran out of time on my other class. So we're going to try to tell you to do a demonstration to show you that this is true. Okay, so you're all familiar, I hope, with the equation y equals mx plus b, right? You guys remember that from Math 1010? The camera, yeah, it should be, oh, is it still pretty blurry? I don't know how to get that thing to focus. There we go. Okay. Y equals mx plus b. You're familiar with that? Okay. In the book, this is the equation I prefer because most people are familiar with it. In the book, they write that as y equals b0 plus b1x. It's the same thing. Okay. I kind of prefer this, so I'm going to try to write my equations in this form, but it's the same thing. Okay. So have you ever wondered how they came up? You know, like in Math 1010, they're like, oh, here's this equation, plot it. And have you ever wondered how they came up with that equation? No. Today you're going to learn. Okay. So your m, which is b1, it's the same equation, is going to be your correlation coefficient times s sub y over s sub x. And your b, which is b0 in the book, is going to be y bar minus m times x bar. Okay? Those are your two equations. So we're going to show you how this works. Let's open up that same spreadsheet we had open yesterday, which is the scatter plot we did yesterday. So just really quickly, I'm going to pick on Preston because I remember your name today. Do you remember how to create a scatter plot?
Yeah. You would just go to charts.
You're going to highlight your data first, right?
Yeah.
Highlight your data. Go to.
You're going to go to charts and then go to scatter.
Go to insert.
Scatter.
Insert scatter. Boom. Okay. We can add some axis titles here really quickly. So this is club head speed, which is in miles per hour. And this is in distance, which is yards. Okay. And then this is hit a golf ball on 70-degree day with no wind. Okay. All right. So now, Excel, here, I'm going to let Excel draw this line here, but I don't want it to go too far. Does anybody know how to draw a line on Excel? Some of you did it on the test and you weren't supposed to. Oh, wow. See, all you people that see the plus sign. I've never done it that way, but that works. Okay, so you can add a trend line on there. Okay. Now, that trend line that you're adding there is actually the OLS line here, this Ordinary Least Squares line. Okay, because it's the best line that you can draw. Now, I want to come up with the equation y equals mx plus b. I don't think I showed you the cheater method for finding the correlation yesterday, did I? Would you like, now, if you use the, let me ask you this. On the test, if you use the cheater method to find the correlation coefficient, how many points are you going to get? 0. Okay? But I'm in a hurry today, so I'm going to show it to you. But I will say this. If you want to check your answer on the test, you can use this command to check your answer. Just don't let that not be the only thing you do. Okay? So if I find the correlation coefficient, the cheater method is equals CORREL, equals coral. Now, it's asking you for array 1. That means your X data. So what I'm going to do is I'm going to highlight my X data just like this. Then I'm going to press a comma, and then I'm going to highlight my Y data. So they should be 2 different colors. Does that make sense? Then you're going to close your parenthesis, and you're going to press enter, and voila, that's all that math we did yesterday. We took the whole class period. We did it in like 10 seconds today. Could have done it even faster if I wasn't talking. Okay? So that's your correlation coefficient. So yes, you can check your answer on the test, but don't let that not be the only thing you do. Okay? Now, according to this, I need to find the standard deviation of X and Y, and I also need to find the mean of X and Y. So let's go ahead and find the standard deviation. Oops, and that's equals STDEV of the X. And I'm going to copy that to there. And let's do the mean, which is the average of these, X and Y, okay. Now, now we want to find my slope. Okay, so my slope in this case, according to my equation, is my correlation coefficient. So I'm going to click on my correlation coefficient. I'm going to multiply that by the standard deviation of Y. What is my standard deviation of Y, Gabriel? What's that? Of Y?
Your standard deviation is
7.74. I'm going to divide that by.
Divide that by the standard deviation of X.
Which is? 2.29, perfect. Okay, so your slope is 3.1661. Okay, Shay, can you help me find, so I'm going to call that the slope M. And then I need to find the y-intercept b. What's that? The equation's right here. M equals, it's the correlation coefficient 0.938 times your standard deviation of y, which is 7.74, divided by your standard deviation of x, which is 2.29. Okay? All right, so Shay, now you need to know that number to do the next part, but Shay, can you help me figure out the y-intercept? You're lost? Where are you lost? Okay, so you've got all the numbers here. Oh, where's your correlation coefficient? Oh, the cheat way, okay. So equals your correlation coefficient times S sub y, which is 7.74, divided by the 2.29. Okay? Are you good now? Okay. Now, Shay, help me find the slope. Not the slope, the y-intercept. So B equals, what does this say? The mean of y, the mean of y is 266.75 minus the m, which is 3.1661 times mean of x, which is 101.875. Okay? So what is the equation of the best fit line for this data? Yeah, but I don't, what's the m? So y equals, keep going there. Caitlin, just give me the real numbers.
So it's going to be y equals 101.875.
No, m, what's m? 3.1661 times x plus the b. What's the b? Negative 55.7966. Okay? So you just found that equation. So now you can go write a Math 1010 book, right? Tell people to graph the y equals mx plus b. Okay? Now, Excel will tell you that answer as well, so you can check yourself. Okay? And you need to check yourself so that you can do section 4.3 correctly, in case you get 4.2 wrong. Okay, so here's how you find that equation. If you pick a point, any point, such as that point, right-click the point, go to Add Trendline. It pops up this. Then you can display the equation and the R-squared value. Look at that. That's the same equation that we came up with. Look at that. Pick a point, any point, right-click, go to Add Trendline, and there's your equation and your R-squared. I did it twice. Okay?
So the R-squared is 50 times the correlation.
Ah, very good. R-squared, what is that? R-squared, as Caitlin said, is your correlation coefficient squared. It's exactly what it is. Okay, now in the book, they give it a special name. The special name is called the coefficient of determination. Determination. I don't know anybody that calls it the coefficient of determination except for the book. They just call it the R-squared value. Okay? So your R-squared value, it tells you the percent of variation explained by the model. In our case, y equals mx plus b is our model. Now, as you look here, let me go back to here for a second. Okay, as you look here, there are other types of regression. We're doing linear regression. Now, just watch here, but you'll see the equation change. Oh, I got to split it on here. So you'll see this equation. Let me finish first. You'll see this equation change based on different equations, okay? You can also just display your R squared. Now, I'm not gonna have you guys go poking around here. I just want to explain to you that there are different methods. The only method that we're going to deal with is linear regression, okay? Now, as you look at this, your R squared is 0.8811. So what that tells me is 88% of my variation is explained by the model, which means what percent is unexplained? 12%. You guys all whisper. You can say it out loud, it's good, okay? All right, so basically 88% of how far the ball goes explains on how fast I hit it. Now, as we look at this, look at here. I've got two points here, okay? So this point here, one time I hit the ball 100 miles an hour, it went 257 yards. Another time I hit the ball 100 miles an hour and it went 263 yards, it went farther. Why did it go, I mean, it should go the same, right? If it was the same, it would have ended up, if I look at that number there, I can see that number, if it was on the line, it would be about 261 yards, right? So why would go farther one time and not the other? What are some reasons why that might be? Just a second. The spinning, what'd you say? Head angle. You guys are big time golfers. I don't worry about stuff like that. But yes, you're right. Head angle. How about it hits a pebble and bounces back? How about it hits a wet spot on the turf? Or how about there's a little gust of wind even though we said it was a no wind day? Okay? So there's all of these unexplained things. Now, Adam, you had a question. Oh, you were answering. Oh, so you raised your hand before I even asked it. Okay. All right. So, all right. So we've got 12% unexplained. Now, the idea here is, this is where we're going to get into, so these areas here, this vertical distance here, that's what we call a residual, which is the observed minus the predicted. Okay. What'd you say? Yeah, so you can see here, this is the residual here, the distance, so it went 3 yards farther and 3 yards less, roughly, than I would have expected. So let's figure out our residuals, okay? In order to find out our residuals, we need to figure out what's our predicted. The observed minus the predicted, okay? So according to this, okay, I can use this y equals mx plus b line here, and I can predict how far it should have gone if I hit it 100 miles an hour, okay? So in this case, it's going to equal y equals, and I'm going to pick my slope here, 3.1661x. I'm going to F4 that because I don't want that to change, times my x, which is, in this case, 100 miles an hour. And I'm going to add my y-intercept, which is negative 55.797, okay? So I would have, and I'm going to F4 that one too, because I don't want that to change. So I would have predicted, just as the graph shows here, it's about 261. Yeah, I would have predicted, according to this equation, it would have gone 260.8 yards. Okay, so I'm off by almost 4 yards. Does that make sense? I'm going to copy this down. And so that's my predicted. So I can see the predicted for all of those. Now my residual equals the observed. It went 257 yards. I would have predicted it would have gone almost 261 yards. I'm off by about 3.8 yards. Does that make sense? It's simply the observed 264 yards minus the predicted, which is 267. Okay, I'm going to copy that down. Okay, so what I can do now is I can create what we call a residual chart. Okay, so I'm going to take my speed, my x values here. I'm going to compare it with my residual chart, my residuals. Okay, I'm going to insert a scatter plot. This one I'm not so concerned about labels, but my question to you is, Maybe I'll do it this way. I'm doing a scatter plot with this. Does this look like a null plot to you? Yes. Okay. So you can create a residual plot. Residual plot. We hope for a null plot because it means there is random error. Okay. Now there's a problem if you see some sort of a pattern. Now, one of the common is what we call the megaphone. Megaphone. Okay. So you see something that looks like this. That's a megaphone, and it could be in the opposite direction. Could be like this, something like that. Okay. It's not going to be that straight, probably. Or it could be some sort of other pattern. You know, if you saw something like that, that would be a problem. Okay, because it would indicate that your error is not random. Okay, we want our residual plot to be a random error because it indicates that you have it's normally distributed. Okay, if you see a pattern, that indicates that there's a problem with it. So in this case, let's say you've got a megaphone pattern, then you might want to reconsider whether regression, linear regression, I should say, linear regression is a good idea. Okay, you might want to pick one of those other methods. Now, I'm not going to ask you to pick another method. I'm just going to say, I mean, that's really more advanced. All I want to do is I want you to plot the residual plot, tell me if the error looks okay. If it looks something like this, then you're going to say, yes, linear regression is a good idea. If it looks like a megaphone, you're going to say, no, you might not want to do linear regression. Okay? Now, we're out of time. I just want to mention one other thing. Okay? And normally I show this, but I'm out of time. You can also find the residuals squared. Residuals squared. So if I take and I square this number, and I copy it down, and then if I find the total, the sum, okay, I'm going to get a sum of 49.8, whatever, okay? So I told you that ordinary least squares was the best line you can make. And normally I'd have a little bit more time, and I would actually do another method. Like, for example, do you guys remember the equation y minus y1 equals m times x minus x1? Okay, that's called point slope. If I had time, I would do this again with the point slope method, because you are all familiar with that. And you would find that when you find your residual squared, you would get a bigger sum than 49.8576. Or any other method that you picked, you know, you could pick the orthogonal method or the horizontal method, or, you know, there's lots of different ways to draw that line. What I'm telling you is ordinary least squares, that's the best method. You're going to have the smallest sum of your residuals squared. Now, the last thing I just want to mention, I know this is a little bit confusing. A lot of you are going to just be like, yeah, I'm just going to forget that. I'll just miss that problem on the test. And then it's going to come back in chapter 14, and you're going to groan. Okay? So this is going to come back and haunt you. Okay? So please learn this the best you can. So we covered 4.2 and 4.3 today. So the quiz tomorrow will be 4.2 and 4.3. So see y'all tomorrow.